Modern infrastructure is reliant on data to make determinations about risk assessments, conditions surveys, maintenance planning, and more. Oracle Analytics makes it easy to transition from a reactive to a proactive maintenance and management strategy. These strategies will more efficiently prioritize resources and improve public safety. By facilitating an analytics-driven continuous improvement mindset, infrastructure analysts are able to monitor and evaluate conditions, plan operational maintenance, and mitigate infrastructure damage that can cause costly disruptions and delays. The Daily Tolls Overview page highlights all the toll transactions that were processed between January 2015 and October 2016. We can immediately see that almost 215 million vehicles passed through the toll plazas in that period. Toll plaza data is a great medium to understand the volume of traffic that moves across critical infrastructure. To take a closer look, we will right-click into August 2016 to drill to the attribute of facility. This will dynamically change the entire dashboard to show the data for that month by each toll plaza location. We immediately notice that plazas 4 and 8 receive the least volume of traffic and that plaza 7 receives the highest number of cash payments. Our analysts and planners can use this information to make determinations about maintenance projects, signage placements, and staffing. As we look at the occurrences of violations, we need to examine the time blocks during which violations are more likely. We see that peak evening rush hour times such as 4, 5, and 6 p.m. experience the highest volume of violations. When we filter to include only those 3 hours, we also see that Toll Plaza 9 and 6 experience the most violations. Our analysts and planners can possibly reduce the number of violations by increasing signage or offering more cash payment lanes at those locations. A strategy to minimize costly disruptions and to extend the longevity of critical infrastructure is to analyze the periods of time where the tolls experience the least volume of traffic. First, we must filter to show all toll transaction types. Then, by utilizing the at-a-glance conditional formatting on the calendar heat map visualization, we can see the days of the week that would be most available for lane closures or other requirements of inspection and maintenance projects. Historically, a pre-summer inspection has always been performed. We can see that April 21st has the least amount of traffic. When we filter to that date, the table on the left of the page will change to show us the toll transactions by hour for that date. We now need to find the hours with the fewest toll transactions. To do that, we will filter by Easy Pass Count to show the bottom 10. The time period analysis now shows the optimal hours to perform the inspection. Heavier traffic does not necessarily only mean volume of vehicles. Larger and heavier vehicles also contribute to the wear on infrastructure. When we look at the toll plaza traffic by vehicle class, we can see that toll plazas 2 and 7 have a higher than average count of heavier vehicles from Class 5 or large delivery and utility trucks to Class 9 or heavy freight trucks. Knowing this, our planners and analysts can schedule inspections on those facilities more frequently to ensure that the infrastructure is conditioned for the traffic needs. Facilities 2 and 7 are positioned on the perimeter of the city and receive the bulk of the traffic volume. Disruptions to those facilities would lead to costly delays. To expand our analysis, we can switch to the editor view. It is here that we can explore the data in more detail. By using the explain function, we can understand the lane mode attribute at a granular level. Explain highlights the facts, key drivers, segments, and anomalies of a selected attribute. Next, we can use Auto Insights, an AI-powered tool, to scan our data and make recommendations for visualizations and solutions that we may not have considered. It is important for data to be easily understood and digested by all end users. By using a machine learning-powered language model, data is automatically transformed into a language narrative. This model scans the selected data and returns relevant content to enhance the understanding of the data. Oracle Analytics works to improve the aging infrastructure analytics cycle by providing easy-to-use, out-of-the-box capabilities. Embedded no-code AI and machine learning can help to proactively identify assets that should be prioritized for maintenance. Built-in last-mile data prep can blend information from various data sources, internal or external, to gain a complete view of assets and their status. The Unified Data and Analytics Platform provides the ability to deliver more impactful outcomes by better understanding asset states and finding more effective solutions.